You might not believe this, but the gearbox gear shaft right here, which was perfectly fine before it broke, was deemed repairable by a veteran mechanic in Peshawar, even in its mangled snap state. He insisted it didn't need replacing. A few simple, specific steps were all it took to restore it to its original condition, using nothing more than a standard universal lathe. After precisely measuring the total length with calipers, he performed a dazzling series of operations, and that broken shaft, which otherwise would have been sold as scrap, was restored to look brand new. The final result was truly astonishing. So how did he pull it off? Obviously, glue wouldn't hold a brake like this, and the gear shaft's steel was extremely hard. Direct machining risked chipping the tool. The mechanic first had to apply high heat to soften the metal. Machining the fracture surfaces flat was the first step. But this created a new problem. The overall length of the shaft had been reduced. Simply joining the pieces now would result in a length deficit and insufficient strength. It would snap again under stress. However, the mechanic had a unique method to ensure a rock-solid repair. Machining a step feature into the drilled hole was the key. He finished one half and set it aside, then moved to the other, which was exponentially more difficult to machine. Since the gear shaft endures immense stress during operation, a simple stepped interference fit, even if hammered together, would likely fail again. So building on the hole in this half, the mechanic machined a crucial feature, an internal thread. This set the stage for a design combining a threaded connection and a stepped joint to distribute the load effectively. With his masterful craftsmanship, he successfully cut the threads, and everything was ready. Only the final and most critical piece of the puzzle remained. For this, he used a scrap piece of round steel. After cutting off the excess from one end, he machined an external thread to match the internal one he'd created earlier. The other end was much simpler to handle. It simply needs to be machined into a step structure with a raised section. This component serves as a connector while simultaneously compensating for the missing length. To ensure a precise, tight fit during assembly, the tolerance must be kept within 0.02 millimeters. However, the craftsman immediately faced another challenge. The machined steel connector was smooth and cylindrical, making it incompatible with the spline structure of the drive shaft. Yet this didn't stump the craftsman. His next move was truly eye-opening. It was a masterstroke that commanded total respect. He marked out the spline pattern on the component, and after precise positioning, began drilling a ring of small holes matching the number of spline teeth. By now, you can likely see the craftsman's strategy. Once drilling was complete, the stepped ends were interlocked and secured, and the threaded end was tightened, effectively reconnecting the two broken shaft segments into a single unit. He then started the lathe to turn away the excess material surrounding the drilled holes, gradually revealing the spline grooves hidden beneath. It goes to show, there is nothing this craftsman can't do. After welding the spline connection points securely, the job wasn't quite finished. One final step remained, turning down the raised weld spots to make them smooth and uniform. Finally, he used a grinder to smooth every weld point until the surface was perfectly even. This broken gear shaft, once destined for the scrap heap, was restored to like-new condition. The craftsman noted that